Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I read the abstract of your report, and I'm really intrigued by the concept of combining traditional machine learning models with large language models, LLMs. Can you tell me more about why this hybrid approach is necessary and what benefits it can bring to machine learning workflows?
Certainly. The hybrid approach of combining traditional machine learning models with large language models is necessary because it allows us to leverage the strengths of both approaches and overcome their respective limitations. Traditional machine learning models are known for their superior computational efficiency in training and inference, which makes them suitable for a wide range of applications. On the other hand, LMS, like GPT-4, possess advanced language, understanding, and contextual awareness, which enables them to generate high-quality text and perform language-related tasks with great accuracy. By integrating LMS into traditional machine learning workflows, we can enhance the performance, flexibility, and accuracy of the system. The LLMs can provide a deeper understanding of language and context, allowing the system to make more informed decisions and generate more accurate results. This is particularly valuable in tasks that involve natural language processing, text generation, sentiment analysis, and other language-related tasks. Moreover, the hybrid approach allows us to improve the reliability and baseline performance of the existing machine learning pipeline without the need for a complete overhaul. We can simply embed the LMS within the existing pipeline, leveraging their intelligence while retaining the efficiency and effectiveness of the traditional models. In summary, the hybrid approach of combining traditional machine learning models with LLMs brings several benefits to machine learning workflows, including improved performance, flexibility, accuracy, and reliability. It opens up new possibilities for AI applications and allows existing systems to be more innovative and responsive to real-world data nuances.
That's fascinating. It's clear that combining traditional machine learning models with LLMs can lead to significant improvements in performance and accuracy. It's interesting how the hybrid approach allows us to leverage the computational efficiency of traditional models, while also benefiting from the advanced language, understanding, and contextual awareness of LMS like GPT-4. I'm curious about the specific use cases where this hybrid approach would be most effective. Can you provide some examples of scenarios where integrating LLMs into traditional machine learning workflows would be particularly valuable?
Integrating LMS into traditional machine learning workflows can be particularly valuable in scenarios where there is a need for more intelligent, dynamic, and contextual decision-making. LMS have advanced natural language processing capabilities that allow them to understand and interpret complex and nuanced contexts within the data. One valuable scenario is in the prediction stage of machine learning models. Traditional MEL models often use a fixed threshold for classification, which may not capture the full context of the data. By incorporating LMS as an extra layer of thresholding, the system can make more informed and dynamic thresholding decisions. This can lead to improved accuracy and recall, as the LMS can analyze the contextual intricacies within the data and adapt the threshold accordingly. For example, in our use case, integrating LMS allowed us to automate the classification of cases that were initially below the threshold. This increased the recall rate while maintaining a similar precision rate, thereby improving the volume of positive outcomes without sacrificing their quality. In summary, integrating LMNs into traditional machine learning workflows can be valuable in scenarios where there is a need for more contextual and dynamic decision-making, leading to improved accuracy and recall.
That's a great example. Integrating LLMs into the prediction stage of machine learning models to make more informed and dynamic thresholding decisions can certainly enhance the accuracy and recall rates. It's interesting how the LLMs can analyze the contextual intricacies within the data and adapt the threshold accordingly, leading to more accurate classification outcomes. I'm curious about the potential trade-offs of integrating LMs in hybrid machine learning workflows. While there are clear benefits, are there any challenges or limitations that practitioners should be aware of when adopting this hybrid approach?
Yes, there are several challenges and limitations that practitioners should be aware of when adopting the hybrid approach of integrating LMS into traditional machine learning workflows. Some of these challenges include: 1. Data dependency. LMS heavily rely on large amounts of data for training and fine-tuning. However, integrating LMS into traditional ML workflows may require a significant amount of labeled data that might not be readily available. This can pose a challenge in cases where there is limited labeled data, or when the existing data is incompatible with the LM architecture. 2. Data privacy and security. When using LMS, organizations often need to rely on third-party providers for access to pre-trained models or cloud-based services. This introduces concerns about data privacy, as sensitive data may need to be shared with these providers. Ensuring compliance with data protection regulations becomes complex when using external services. 3. Performance and efficiency. LMS are computationally expensive and resource-intensive models. Integrating them into traditional ML workflows may require significant computational power and memory, which can impact the performance and efficiency of the overall system. This becomes especially critical in resource-constrained environments or when real-time predictions are required. 4. Interpretability and explainability. LLMs, such as transformer-based models, are often considered black box models, making it challenging to interpret and explain their decisions. This lack of interpretability can be a significant limitation in domains where transparency and accountability are essential, such as healthcare or finance. 5. Cost and scalability. Integrating LLMs into traditional ML workflows can come with additional costs, such as licensing fees for pre-trained models or cloud-based services. Moreover, as the size and complexity of LMS increase, so does the need for computational resources. Scaling up the system to handle large-scale deployments can become costly and challenging. It's important for practitioners to carefully evaluate these challenges and limitations against the potential benefits when considering adopting a hybrid approach. They should assess the availability and quality of data, consider the interpretability requirements of their use case, and ensure that the system's performance and scalability needs can be met effectively.
Thank you for providing a comprehensive overview of the challenges and limitations associated with integrating LLMs into traditional machine learning workflows. It's crucial for practitioners to be aware of these factors and carefully evaluate them before adopting the hybrid approach. The challenges related to data dependency, privacy, and security highlight the importance of ensuring that there is a sufficient amount of labeled data available for training and fine-tuning the LMS. Additionally, the need to rely on third-party providers may introduce concerns regarding data privacy and compliance with regulations. The performance and efficiency considerations are also significant, as LLMs are computationally expensive and resource-intensive models. Practitioners need to ensure that they have the necessary computational power and memory to effectively integrate LLMs into their workflows, especially in resource-constrained environments or real-time prediction scenarios. The lack of interpretability and explainability in LMS is another important aspect to consider, particularly in domains where transparency and accountability are crucial. Finding ways to address the black box nature of LMs and provide insights into their decision-making can be a challenge. Lastly, the cost and scalability implications highlight the financial aspect of adopting the hybrid approach. Practitioners need to account for potential licensing fees and the computational resources required to handle large-scale deployments. Overall, Practitioners should carefully weigh these challenges and limitations against the potential benefits of integrating LLMs into traditional machine learning workflows to make informed decisions about implementing this hybrid approach.
Integrating large language models, LMS, into traditional machine learning workflows can come with a few challenges and limitations. One challenge is the computational cost and resource requirements of LLMs. LMS are typically large models that require significant computational power and memory to train and deploy. This can make it challenging to integrate them into existing ML pipelines that may not have the necessary infrastructure. Another challenge is the fine-tuning process of LMS data. Fine-tuning an LM requires a large amount of labeled data, which may not always be readily available. Traditional ML workflows may not have access to sufficient labeled data to effectively fine-tune the LLM, limiting its potential performance. Additionally, LMs are trained on a vast amount of diverse data, which means they may exhibit biases present in the training data. When integrated into traditional ML workflows, these biases may be propagated and affect the outcomes of the system. It is crucial to address and mitigate these biases to ensure fair and unbiased results. Finally, LMS may also suffer from the problem of explainability. Traditional ML models often provide interpretable features and explanations for their predictions, allowing users to understand the reasoning behind the model's decisions. On the other hand, LMS, being complex neural networks, can be more challenging to interpret and explain. This lack of interpretability can be a limitation when integrating LMS into traditional ML workflows, especially in domains where explainability is a critical requirement. Despite these challenges and limitations, there are approaches and techniques available to overcome them and harness the benefits of LMS within traditional machine learning workflows. It requires careful consideration of the specific use case, available resources, and the expertise of the ML team to ensure a successful integration.
That's an excellent summary of the challenges and limitations associated with integrating large language models, LMS, into traditional machine learning workflows. The computational cost and resource requirements, along with the need for labeled data for fine-tuning, can indeed pose significant challenges. It's crucial to have the necessary infrastructure and access to labeled data to effectively incorporate LMS into existing ML pipelines. The issue of biases present in the training data is also an important consideration. Since LMs are trained on diverse data, biases within the training data can be propagated and affect the outcomes of the system. Addressing and mitigating these biases is essential to ensure fair and unbiased results when integrating LLMs into traditional ML workflows. The lack of explainability in LMS is another limitation that practitioners should be aware of. Traditional ML models often provide interpretable features and explanations for their predictions, while LMS can be more challenging to interpret due to their complexity as neural networks. Finding ways to enhance interpretability when integrating LMs into traditional ML workflows is crucial, particularly in domains where explainability is a requirement. Despite these challenges, it's encouraging to know that there are approaches and techniques available to overcome them and harness the benefits of LLMs within traditional machine learning workflows. This requires careful consideration of the specific use case, available resources, and the expertise of the ML team. By addressing these challenges and leveraging the strengths of LMS, practitioners can successfully integrate them into traditional ML workflows and unlock their potential.